Dimensions and error analysis is one of the important topic in the Neet first syllabus. We have studied about these topics in grade 11th, chapter number 2, units and measurement chapter. See, one question we can see like this way. The dimensions of A into B in the relation E is equal to B minus x square by AT, where E is the energy, x is the displacement and t is the time, R. So here we have the question like this way. E is equal to B minus x square by A into t is the equation given for us. Now it's given x is in distance, L length, and t is in time. So it's in meters and in second. That means x has the dimension of length square. So we can say here dimension of x square is equal to L square. The same will be for B also, because B minus x square is a positive addition or subtraction term. Both will have same dimensions. So dimension of x square and B is same. This equation you can rearrange as A is equal to B minus x square by E into t. So dimension of this is nothing but L square divided by dimension of E is energy, that is mL square t power minus 2 into t is time t. This is for energy and this is for time. So if you resolve into this L square cancels, t power minus 2 and t power 1 cancels it, so it will become m inverse t inverse. That is for A. Now dimension of A into B you have to find out. So for A we have m inverse t power minus 1 into, for B we have already L squared. So L square. This is nothing but m inverse L square t inverse. This is the answer for this question. So here, so if you get a question for dimensions, you can use the concept of dimensional consistency. So here you can rearrange the equations. B minus x square, you have same uniform dimension should be there. Then we rearrange it, we substituted. I hope you got this concept. But another part of the question is, a particle starting with certain initial velocity and uniform acceleration covers a distance of 12 meters in first 3 seconds and a distance of 30 meters in next 3 seconds. The initial velocity of the particle is. So here in this question it says that a particle covers 12 meters. So S is equal to 12 meters for first 3 seconds. It travels a distance of 12 meters for first 3 seconds. So you could write this on, we have S equal to ut plus half a t square. S is the distance, u is the initial velocity, and a is the acceleration, t is the time taken. So this equation we can write as 12 is equal to u we don't know, t is 3t plus half into t square is 9, so half a into t square is 9 by 2 a square is there, that is 12. So this can be written as 3t plus 9 by 2 into a, that is 12. Equation number 1 we get. Now, and next to 3 seconds it is again travel a distance of 30 meters. Here it says that in the next 3 seconds it travels a distance of 30 meters. So here first 3 seconds is 1. So total t is equal to 3 plus 3 seconds, that is 6 seconds. It travels a distance of 12 plus 30, that is 42 meters it travels. So for this concept, S equal to 42 meters and t is equal to 6 seconds. If you put this equation here also, we get 42 is equal to, S is equal to 42, is equal to 6u plus half a t square, half into a into t square is 6 square, that is 36. So this you can write as 42 is equal to 6u plus 36 by 2 is 18a, that is equation number 2. We have to solve this 1 and 2, then you will get the correct answer. So here see, here 1 divided by 2 is there, you take the LCM 2 here and rearrange. So this first equation can be written as 12 into 24. So 24 is equal to 2 into 3 6, 6t plus 9a. So these two equations you solve it. So 6u actually it is. and you'll get this way 6u and 6u. Suppose 2 minus 1 you do. So 2 minus 1, it's the first equation. 2 minus 1 gives you 42 minus 24. LHS, you have to subtract this one. Then 6u will be cancelled. 18 a minus 9a. We get 9a is equal to 42 minus 24, that is 18. So a is equal to 2 we are getting, meter per second square. A is equal to 2 meter per second square. This a you substitute here, you will get u, the initial velocity. So you will get u is equal to, a is 2, you got it. So 9 into 18 is there. So 6u is equal to 24 minus 18, that is 6. So u is equal to 1 meter per second. D is the option for this. So we use the distance formula here, S is equal to ut plus half at square. Equation we used for first 3 seconds means t is equal to 3 seconds you can substitute. We got an equation 12 meters. Then next to 3 seconds 30 meters. So total for first 6 seconds you have to do this equation. So directly don't put here 30 and 6 here. So total distance will be 42 meters in first 6 seconds. So here t means total duration of time it is. I hope you got it. You will get u. So solving this equation, you will get this answer. In the given figure, a is equal to 15 meter per second square represents the total acceleration of a particle moving in the clockwise direction in a cycle of radius r is equal to 2.5 meters at a given instant of time. The speed of the particle is. So here in this question, we have a circular moving body. The radius is r and this is given the acceleration, total acceleration at an angle of 30 degree with the center, with the radius. So the body is moving along this path. So its acceleration is given this way, total. And its value, total acceleration we have 1.15 meter per second square. So a is equal to 15 meter per second square and r is equal to 2.5 meters. So radius and total acceleration is given. Now in a circular motion, centripetal acceleration is there. The centripetal acceleration is always towards the center. So along the radius. So if this acceleration, if you resolve along this one, then we get this centripetal acceleration AC is equal to A cos theta. The cos theta horizontal component will be the centripetal acceleration. This AC will be equal to A is 15 into cos 30 degree. Cos 30 is root 3 by 2. So 15 into root 3 by 2. That is 7.5 into root 3. That is AC. Root 3 is 1.73. So you can substitute it. 7.5 into 1.73. That is AC. We have to find the speed of this particle, this moving particle. Speed we have in centripetal motion, we have AC is equal to V square by R. This gives you V is equal to root of R into AC. So that is equal to root of 2.5 into V is equal to 2.5 into AC is given 7.5 into 1.73. If you find the multiplication and take the root, it will become almost 5.7 meter per second. V. So we got the concept of circular motion here. Centripetal acceleration we got as a resolution. And then centripetal acceleration equation is V square by R, linear velocity squared by radius. So V is equal to root R into AC. Then V is equal to 5.7 meter per second. I hope you got it.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306000679.